just go ahead and ask, like we always do. I always want to ask questions. So let's see here. That looks pretty good. So what we're going to talk about is function composition. Okay. So I think I'm going to have to change this a little bit here. There we go. Just a little bit too big. There we go. I changed the pen tip on this thing the other day, and when I did, it became thicker. I don't like it when it joins letters together too much, but function composition, and then we're going to do inverses. Okay, so with function composition, I was thinking about, how could I do this and have it sort of set a ground or a foundation for what we're going to do. And so I started thinking, well, I'm going to talk about this little scenario deal. All right. So you kind of have to maybe bear with me on this, and as I go through this situation. So, and you can make comments along the way. Here's the deal. So I like Chipotle. Okay. I don't eat a lot of fast food, but I do really enjoy. I try to stay away from it actually, but I do really enjoy Chipotle, even though they've had all those food issues, right? I don't really care. I still kind of like it, and this is actually kind of an example of function composition. If think about this. So I'm walking into place, right, and you're gonna enjoy this story because I have certain ways I like my Chipotle thing, and you'll probably enjoy that. So I walk in there, and they're always nice and greet you. And hey, what do you want? And so I usually tell them I want a steak fajita burrito. Okay, that's what I really like those. So then they get the little wrap thing, push it in the press thing. I don't even know what it's called, right? And they heat it up. So I'm going to say that there's an employee. We're going to call him Imp 1. Okay, employee 1. And what they're doing is they take my little wrappy thing here. I'm going to see it's kind of tannish, right? So they have this here. Maybe it's white, but we'll go like that. And what do you want? I can tell them, okay. So what do you want on it? And I go, oh well, I want steak and peppers and onions and stuff. And they ask me, you want beans? And I go, no, because I don't like beans. I don't like kidney beans, and I don't like black beans, and I don't like pinto beans. I don't like any beans. Just don't like them. So they don't put that on there. The next thing they ask me, hey, do you want rice? I go, no, I don't want any rice either, because I don't like steamed white rice. I'm okay with like fried rice, like in pork fried rice. I really like that, but otherwise I don't. So my inputs here that I have on here right now is I got a little bit of steak stuff here and some peppers, right? Okay, so I got that on there. Okay, so then after that's over with, point number 2 takes, oops, I don't want that color. Oops. Stay consistent here with my purple. So then, of course, I choose the wrong purple. So then employee number 2, right? So they pass this down the line, right? I mean, I'm sure people have been there. So they have this, and now it's just passed down the line. So there's my little input things, and I'm passing it down the line. And then the next person says, hey, what do you want on this thing, right? Well, it's already got the little bit of steak stuff on there, okay, right in here, and my green peppers, okay, right here. Oops, that's supposed to be green. There we go. Why is it not coming up green? There we go. And some onions, right? So I say, hey, what I really want is a lot of pico because I like that stuff. And actually, the last time I went to one, they didn't have any pico, and I thought, wow, how can you not have that? But then maybe they're short of workers, or the pico truck's stuck out somewhere in the highway or wherever they're stuck at. you know. Anyway, they didn't have any. So, but yeah, pico and then some cheese and some lettuce, and I get it all fixed up, and that's how I like it, right? So then they add those things. Okay, so they add the little pico-ish stuff when they have it, and some more, and some cheese and junk like that. I mean, you're kind of getting a feel for, I don't know what color I'll make the cheese, kind of a light orangish color or something here. All right, so there we go. So then from that, right, I get this finished product, okay? And I'm all excited because I get this nice finished product of what it is. And they wrap it up for me. And there it is, something like that, right? So this is actually a really good example of function composition, all right? Because what happens with function composition, if we look at these two employees as my two functions, say this is f of x and this is g of x here, all right? I go up there and I give them some input, right? This is what I want. They put the stuff in there, and then they take that and they pass it on to the next employee, who happens to be the next function. So I give them an input and they have an output, right? They take that and they slide it down. Well, that output now becomes the input for employee number 2. So they have this and they say, now what can I do for you? Well, here's what I want, right? So then they put stuff on it, and then finally it comes out and I have this yummy burrito thing that I like to eat. So that's exactly how function composition works, all right? You have a function and you give it an input, all right? So let's say that we have a function here, all right? And we'll call this f of x, okay? And I have an input, right? So 1, 2, 3, 4. So there's my input. So then I have an output for that, right? Whatever that might be. Say maybe it's 3, 5, 7, and 9. So 1 goes to 3, 2 goes to 5, 3 goes to 7, 4 goes to 9. All right. Then I have this other function, say g. I don't know why this thing keeps writing so thick. That's a little better. The input for g normally would just be some numbers or whatever, right? But the input this time becomes this output. And this gives us an output here. So this goes here, 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 here. And I'm just going to go this and this and this and this. All right. But see how these two things are the same. So the output for one function becomes the input for the other one. And that's what function composition is all about. So if you can latch onto something, maybe it's a little story or scenario I told you, that's great. But that's what we want to figure out, is that the output becomes the input. Okay. So when you're doing function composition, that's kind of what it looks like. So what I'm going to do here is I'm going to zip over to 286. Now this is, if you're following along because you want to, let me get you back to the page that we would be on here to start with. And it's 281. So if you're interested in 281, that's where we start at, okay? So this is the whole idea. So what would this look like? So then if we had a domain here, okay, so the domain would be 1, 2, 3, and 4, okay? But the range would be the final output, okay? 10, 11, 10, 11, 12, and 13, okay? All right, that is the output. It doesn't, inside here, oh, I don't know what happened there. Inside here, okay, is just the output becoming the input. We really don't record those. We're interested in this domain here and this range here, okay? So if I was to write this, here's what I would have. So we would go 1 to 10, okay, 2 to 11, 3 to 12, and 4 to 13. So that's what it is, okay? So 1 to 10, 2 to 11, 3 to 12, and 4 to 13, that is our function composition, okay? So we would actually call this g of f of x. And I'm really sorry that these things are, this thing is really sensitive, I think, and that's why I'm getting these goofy looking crossovers to when I lift my pencil. All right, that's what that is. So this is, again, this is called function composition. Now, I wrote g of f of x there, all right? The textbook likes to write it as f circle g fog. They put parentheses around that, and then they would put an x like that, okay? I've never been real fond of that way of writing it. I've always kind of liked this one instead, but, you know, they use this guy. And it's kind of the same thing, except the g function's on the inside here, where in this one the f function is on it. This one f is on the inside. Here g is on the inside. All right, and you'll see the difference as we do start doing some problems. Okay. All right. So let's just kind of start messing around with this a little bit and doing some problems. So we're going to find the fog is just f of g of x, so it's f of g of x. And it's just composition. It's just another way of writing it. Okay, so I'm going to put find the compositions. Move this over here. So I'm going to give you a couple different functions here. So we'll do f of x, and we'll do a 2x minus 3. We'll do a g of x, which will make an x squared minus 1. And then we'll do an h of x. And where we'll just go x over 2 plus x. Something like that. Okay? So there's my three functions. And what we're going to do then is just do some function compositions. All right? And I'm going to kind of write them both ways, just so you kind of see both ways. All right? So let's do this one first. We'll go f of g of 2. Okay? Which be written as FOG in parentheses and 2 on the outside. So that's how that's both ways of how they're written. So what you do with function composition is you start on the inside first. You always start inside and work your way out. So you start with the g function. So then what we're going to do is we're going to take this 2 and we're going to substitute that in to the g function. All right, so I'm going to get this. So I'm going to get x, we're going to get 2 squared minus 1. So wherever I see an x, I'm going to stick that 2. So now I'm going to continue to work this out. So that's 2 squared, which is 4, minus 1 is 3. So 2 is the input, right? So 2 is the first input. Now that 2 goes into the function, things happen. Out comes 3, right? So now we got 3.
Where did you get that 2 from?
Oh, this 2 right here?
Yeah.
Oh, that's just part of the problem. Usually you'll have something there.
So you just made that up.
Mm-hmm.
Okay.
So now what we're going to do is take this 3, because it's the output. Now it becomes the input into the f function. All right, so then now I'm going to take and figure out, well, what's f of 3? All right, so I'm just going to try a little arrow here. So I'm going to go 2 of 3, or 2 times 3 minus 3. So 2 times 3 is 6, minus 3 is 3 again. So my answer, my final answer is 3. That's my output. All right, so I started with 2. Okay, it went in right to the G function. G function does something to it, spits it out. Here comes this number. Put that into the F function, and it spits out the final output. Okay, so that's how it works. The output becomes the input in the middle there, and then here's your starting value, and here's your final output. Okay. So let's try let's try, this of course is the same thing. Okay, it's not any different, it's just written differently. Let's try another example. Okay, so let's go with f of h of 1. See what that is. Okay, of course this would be written as f o h of 1. So then I take the, do the inside out, right? So you start with the inside, so that's h of 1. So I come up here to the h function. Okay, there it is. Wherever I see an x, I'm going to put a 1 there. So this is going to give me 1.5. So that becomes my output, right? So 1 is the input, 1's the input, 1.5 becomes the output. Now I take that 1.5 and I put into the f function. So this is going to be 2 times 1.5. Looks like I got minus 3 there. So 2 times 1.5 is 3. Minus 3 gives me 0. So my answer is 0. So 1's the input and 0 is the final output. Okay.
I have a question.
Yeah.
When you get that number that spits out of that first equation, to put it into another equation, you can pick any one except the one it just came out of. Does that make sense? It doesn't have to be a certain one.
I think I know what you're asking. So, for example, in this case, we did h of 1, right? So that gave us 1.5. That was the output, right? Now that output becomes the input, but you got to put it into the f function or whatever function is specified on the outside. Does that answer your question?
Okay, got it.
Okay. So let's try an h of g of, let's do a negative. We'll do a negative 2 this time. So this would be h o g in parentheses of negative 2. All right. So here we go. So again, you start on the inside, right? Always start on the inside. So you take g of negative 2. So then I'm going to take negative 2 and stick it into the g function. So I have to go up here and take a look at it. There it is, x squared minus 1. All right, so I'm going to take negative 2 squared minus 1. All right, so negative 2 squared is 4, minus 1 is 3. All right, then that 3, right, goes into the h function. All right, so then I come up here to the h. Let's see, that was 3 over, I think it's going to be x. Oh, boy. So it's x over 2. Yeah, x over 2 plus x. All right, so now I'm going to go 3 over 2 plus 3. So that's going to be 4.5. So my answer is 4.5. All right. Does anybody have any questions on that part? Ask away if you do. Okay, so let's try this. All right, so let's try this. Let's flip this around a little bit. So what if we went g of h of negative 2? Okay, so that would look like this. And they would put negative 2 in there. All right, so let's figure this out, right? So the negative 2 is going to go into the h function first. So we're kind of reversing it, right? So then that would be negative 2 over 2 minus 2, because I'm putting it into the h function. Negative 2 divided by 2 is negative 1. Minus 2 gives me a negative 3. Okay, so now there's my output, but that's the input into the g function. All right, so it looks like this. So it goes into g. Okay, so that'd be negative 3 squared. And I think it's, oh yeah, minus 1. I got it right there. All right, so negative 3 squared is 9, minus 1 is 8. So one of the things that we notice, right, is that this was h of g. I'll put this down here. And this is g of h. And we notice, hey, they're not the same number. They're different, right? One's 4.5 and one's 8. Well, you might remember that, like if you take a multiplication or addition problem, 2 plus 5 is 7, and so is 5 plus 2. So the order doesn't matter. That's commutative. Right? It doesn't matter for addition, and it doesn't matter for multiplication. The order doesn't matter. But in function composition, it does matter, because when we switched it around, the g and the h, we got a different answer. Right? So function composition is not commutative. It can change. Any questions on that part of function composition? Okay. Again, don't be afraid to ask, right? Because I opened up with saying, hey, this is the one chapter that tends to cause some issues. Okay. So we're going to kind of up the game a little bit on this. All right, so let's go back, and I'm just going to put down these guys here. So I'm going to go with an f of x, and I'm going to put an x squared plus 2, excuse me, and then I'm going to put a g of x, and I'm going to make that negative 2x plus 1. All right. So now we're all of a sudden going to change this a little bit. And what we're going to do is we're going to say, what if we just want to know what this is? So what if we want to know what f of g of x is? All right. And so that would be f of g x. So we don't have numbers anymore, right? Before it was pretty simple. We just take the number, right? Put it into the first function, get the output. Output becomes the input into the ladder function, one on the outside. Well, in this case, I don't have numbers. Okay, so how does this work? Well, what we're going to do here is take this g function that's right here. All right, I'm going to take that whole g function and substitute it in to the f. So I'm going to put that wherever I see an x. All right, so here's what I'm going to do. I'm going to take this whole thing here and put that right in there. So I'm just going to write it out here. Okay, 2x plus 1 squared plus 2. All right, now what we should do is, make it a little more simplified. We can probably square that out, figure out what it is, and then add the 2, and it'll make it a little bit cleaner. Okay, so what I like to tell people is, hey, take this thing, since it's squared, and write it twice, because that's what squaring means, by the way, is multiplying by itself. So if you see that 2, okay, then you're just going to write this thing twice. And then, of course, now we want to FOIL it. And I know I haven't got that plus 2 in there. I'm going to kind of pitch that out in the yard for now. So I'm going to go like this. We're going to go 4x squared minus 2x. That goes to here. And then another minus 2x. That gives me a minus 4x plus 1. And now I'm going to bring that 2 back into the picture. All right, so we have that here. Okay. Darn, X's connect. And that gives me a plus 3. All right. So that's what f of g of x is when it's all in a simplified form, which is probably what you want to do. So again, the inputs, okay, you start out with an input, you get an output, and then that output becomes the input, and then you can finally get your output that you want. All right. So that kind of makes a little bit of a difference in this thing. All right. So let's go ahead and take a look at this. And I think what I'm going to do is I'm going to put it in Desmos, but I'm going to use my main computer on this. I feel a little bit better about doing it on that. So what I'm going to do is stop this share and see if I can get it to view here. Let me do this and share this screen. And the screen I'm going into is Desmos, okay? So in case that you want to go into Desmos 2, you can. In fact, I'll kind of stall a little bit while you're getting that way. So what I'm going to do is I'm going to show you how Desmos handles function compositions. Now, it's not going to do it for you, okay? It's not like, oh, you mean I can just put f of g of x and it's going to tell me what it is? No, it doesn't quite work that way. Well, let's go ahead and type this in. So I'm going to go f of x equals, I don't know why I got that, f of, there we go, x, and I'm going to go equals, and I'm going to write it what it was equal to. So, of course, I kind of forgot what it was. So let me go to view options here for a second and do that. Oh, there it was. Here I got it. So f of x is equal to, come on, there it is, x squared plus 2. So I'm going to put that on here, x squared plus 2. All right, now I'm going to put my g of x down here, all right, and that is equal to negative 2x plus 1. Okay, so now I have two graphs, all right. I'm going to go back to this so that people can see what we're doing. So there that is, all right. So before I graph the composition, I want to talk about this for a minute. So let's clear the blue one off for right now. I'm just going to click. Let's see. Oh, no, wait a minute. I'm going to click it the other way. Okay, so G, all right, here's the G function here. So let me ask you this. What's the domain of this G function? I want to write this down. You guys tell me what it is. We'll put it in blue. What's the domain of the G function? I'll write it down here.
Negative infinity to infinity.
Yeah, negative infinity, all real. Good job. We're getting all kinds of good responses here, right? So it's all real. Okay, so I'm writing that down here, all real. I'm just going to put R so you know what it is. Okay, so then the domain is all real. So I'm putting all those numbers in, right? So then what's the output of that? What's the range then? What's the range of that?
It's the same.
All real.
Yeah, it's the same, right? Good job. Okay, cool. Also all real is great. So here's the deal. So now this, right? Remember this becomes the input to that function up there to f, right? So before we were just looking at one number, but now we're looking at a range of numbers, right? We're taking this range, this actual range of numbers, and those are becoming the inputs. So now this all reals is going to go into this function up here. So I'm going to stop this annotation. There we go. And click on this. Okay. And then I'm going to come down here and I'm going to write this. I'm going to go f of g of x. See how Desmos does it the same way. And now you can see that, look at that, it drew the green one. Okay, so if I turn these off, all right, that's the green one. So the range here goes into the f function, right? And it squares it and it adds 2. Well, if we just simply look at the f function, what's the domain of the f function? Let's do that one. What's the domain of that? Nice D, huh? What's the domain of the f function? Yeah, I'm getting all reals again. Okay, sweet. Okay, so we're getting all reals. So that's good. Because if this domain is all reals, and this range is all reals, and the ranges go into there, that's a good match, isn't it? Because it's just like all reals to all reals. That's perfect. And then the range of this, of course, right? The range of the red function is what? Y is greater than or equal to 2. But if I click off of this thing for just a bit and go back to this, all right, look, oh, hey, it's the same thing. Right? The green one has the same thing. The range is greater than or equal to 2. Right? It doesn't change. Okay? And the domain happens to be the same domain as we have, as we have here. Okay? So this domain of the green one, I'll put it down here, is also all reals. Because these are just parabolas. And the range also is y is greater than or equal to 2. Okay? All right. So that was pretty nice. Everything kind of fit in pretty well there. I see you guys are getting the same things that I am. That's awesome. Okay, so then that was pretty straightforward, right? We're just putting that in there. And we just kind of worked it out. Excuse me, we put the G in for the F and just did some algebra and got the answer, right? So shoot, then that worked out pretty well. Let's try it with something different, okay? So let's go ahead and let's put in some different functions this time. Or let's do this. Let's play around with it differently. We know it's going to be a little different. What if I flip this around? Right? What if I go like this? Okay, g of f of x, right? So now I'm going to take the f and stick it in to where the g goes, right? Into where that x is. So I'm going to see if I can do that down here. So let's see, when I get a negative 2, okay, parentheses, and this x squared is going to go in there. So I get x squared. And we can kind of anticipate that we're not going to get the same thing, right? Because we just saw that. We didn't get the same thing before, so we shouldn't get the same thing again, right? It's going to be, should be different. So then here we're going to get a negative 2x squared, okay, minus 4 plus 1. So I finally get a negative 2x squared, all right, minus 3. Okay, everybody with me on this? We're doing all right? Okay. All right. So the domain and ranges don't change, right? I mean, the domain, let's take a look at this, okay? So let's say, here we go. Let me do, what was this one? Red, okay? So we'll start with red. So let's write the domain of that again. So the domain of the red one, come on, I want red. There we go. The domain of the red one, all right, was, what was it again? What did we say for the red one?
All real numbers.
Yeah, it's all reals, isn't it? Yep, you guys are putting it. Put it in the chat. Don't be afraid. That way, at least I know you're hanging with me. All right, all reals. Okay, good. Now, what about the range, though? What was the range of that f function?
Greater than or equal to 2.
Okay, good. You guys are with me here. Good. Okay. Okay, now let's think about this. So this now, that's the input, isn't it? So now this becomes the input into the g function. All right. Now the g function will take anything, right? It's all real numbers. So it'll take anything, but we're only putting in numbers that are greater than 2 because that's all that we're getting out, right? So it goes back to kind of my little Chipotle thing, right? So if I give it to employee 1, they give me my little steak and the peppers and onions and stuff. That's what the input is. It's not the whole thing with the rice and the beans and stuff. It's just, hey, it's been restricted. Okay, so then when they make the rest of it, then, oh, okay, this is what this guy wants. He's kind of goofy. He doesn't like beans and rice, but that's all right. They don't care. So there you go. So this is a good example. Here we go. So now we're going to change this. So now if my range is just giving me numbers greater than 2, so that means that when I graph this composition, I think it's going to look a little different. So let's try it out. So we're going to go like this. All right, I'm going to click off of this thing, and I'm going to put this in here, and let's see what happens. So then did I do it right? Yeah, so then our domain here, okay. I don't know if those of us did this right. Oh, darn. Well, I'm not looking too good right now. Because it really should have only given you numbers that are, the F went into the G. Because you should only really get numbers that are greater or equal to 2. Okay. It should have restricted it. I think it does it because there's no errors in the domain of that one. So I'll show you where that comes into town. But really you should only have numbers that are greater than or equal to 2 because that's all your inputs are. Okay. But I'll show you one where it does actually restrict the graph. At least I hope it does. It usually does. I'm kind of befuddled right now. All right, so let's take a look at something like that. And then we can take a little break here. So I'm going to clear all the drawings out. I'm going to try this one more time. All right, this time I'm going to change this a little bit. Let's change this to a 2x plus 1. And I'm going to change this to a square root 1. There we go. Okay. So I'm going to, let's stick with this same thing that we have here, the g of f of x. So the f is going to go into the g. All right. So now let's talk about this. Of course, we know what the domain and range is of the f function. That's all real numbers. If I graph it, I get a line. Okay. The g function, though, is a little different. It's going to start here at -1 because we can't have any real numbers and take the square root of them that are negative, right? So we can't take the square root of any negative numbers, -2, -4, -6. All those don't exist. We can't do it, so it has to be greater than -1. So then what I'm going to write here is for the blue guy is I'm going to say that the domain for blue, right, has to be greater than or equal to -1. All right. So the domain range of the f function, which I think was red, was all real. We're all in agreement with that. So now what we're going to do is say, okay, so I get all these numbers coming out of this function, right? All real numbers. There's no restrictions, and I'm going to dump them into this. But the problem is that this domain can only be certain numbers. Okay, it can only be certain ones. I'm getting stuff here. Isn't 2x squared? Did I mess up, Fiona, and write it wrong? I may have. I wasn't paying attention. Sorry. Just yell at me if I don't get you. Never mind. Okay. So anyhow, let's check this out. So now what we're going to do is say, since this domain is different, it's not all real numbers, it's kind of restricted, let's graph the composition this time. Now let's see if Desmos does it right. All right, and see what we get. Oh, there it is. So you see how it has to start at -1, okay, when it does that composition. Now let's figure out what the composition really is. All right, so I'm going to put this in a, let's go with this green. All right, so I'm going to take the f function here and put it into the g. All right, so I'm going to have a square root of 2x plus 1, and then a plus 1 because of this. All right, so now I'm going to keep working on that. So I'm going to take the square root of 2x plus 2. All right, so that's what the composition should be. All right, 2x plus 2. So now let's do this. I'm going to come down over here, put that down here. I'm going to type this in. Y equals square root 2x plus 2. And you can see, ta-da, goes right over the top. Now I look better. Okay, it starts here at -1. It goes over the top. The composition works. All right, and it's all because the domain of this g function has been restricted. So the outputs then automatically become restricted. Right? So that's kind of the tricky parts about function composition, is you kind of got to be aware of that. All right? And what happens. Any questions on that part? Okay. There's a little bit more with function composition that I want to do, but this would be a really good time for us just to kind of take a breath and let some things settle a little bit, and then we can come back and take a look at it. So let's go ahead and see. It's about 7, so let's come back at about 10 after 7, and then we'll do some more function composition and some inverses of functions. That's the second topic. Okay, so let's just come back at about 10 after 7, and we'll go from there. Be back here. I'm going to resume that. Okay, so we kind of left off with looking at, hey, what happens when, the domain of one of our functions is restricted, right? How does that affect stuff? So let's look at that from a different perspective. So let's say that we have f of x. Oh, man. F of x. I'm just going to make it a nice normal 2x plus 2, something like that. And then here we'll go with g of x. And we'll go with the square root again. And we'll just go x minus 1 this time. Okay? So then what we want to take a look at, let's look at both situations, all right, where we're taking f of g and g of f. But instead of looking at them from a Desmos perspective, let's look at it from just a pure non-visual or algebraic perspective, okay? So we want to take f of g of x. Now understand that in most cases, you really don't have to worry about that domain thing. Everything's going to be all real numbers, and it's going to work out great, and you're going to be happy, okay? But the book is going to ask you, all right, at times to say, hey, what is the domain and what is, I don't think it ever asks for the range. If it asks for the range, you pretty much have to just graph it and look at it, okay? I'm looking here, I'm just kind of getting on the right page. So that, oh yeah, we got to do some of those too. Okay. So I'm looking to see if it does where it asks you to find the domain. It says yes. So here's the state the domain of the composite functions. All right, it gives you what they are, and then 4 different choices. All right. So yeah, they're going to, but again, most of the time it's all going to be fine. It's just in these certain situations is where it gets a little hairy. All right, so let's go ahead. We're taking f of g, so that means g is going to slip into here. Okay, so right now my g function, I'm going to put the domain, I think I'll put that over here in like a yellow. And I'm going to say that the domain is x has to be, right, greater than or equal to 1. Are we good with that? Why that is? If not, say speak up or chat up or something. Okay, so obviously we can't, if we put a half in there, we're going to get a negative. We can't do it, right? So that's what my domain is. Okay. So now what we're going to do is look at this domain here, right? So this domain is all reals again. All right, we're pretty cool with that. So I have no issues. So then this square root could just fit right inside there. Okay. And I'm not going to have... this is for the domain of this function, and this is for the domain of that function. Okay. So here is my function here, right? Now, if I look at this, if I was to just flat out give this to you and you say, hey, what's the domain of this? All right, you'd probably look at that and say, well, really the only time I'm going to have a problem is right here underneath the square root. And I just got to make sure that that's always staying positive. So the only way that that's always going to stay positive, if I say, well, my domain's got to be greater than or equal to 1. Oh, well, that's the same thing that we had up here. So in that case, since the f function was all real numbers, that domain kind of carries through all the way through the problem, right? So that again, that was my initial input, right? So that initial input stays all the way through. So when I said, hey, I only want the steak and the peppers and the onions, that's what I end up with in the end. So that's kind of how that works. Okay, so that domain carries all the way through. So in that situation, oh, well, that's not so bad, right? If I graph that in Desmos, I better get the darn right graph so that x is greater than or equal to 1. All right, I better get that. So now we're okay with that. Oh, the range, how would you do it? You just have to graph it and see what it looks like, all right, and go from there. But they don't ask for ranges. They only concentrate on the domains. So then let's do this now. So let's flip it, right? So now we're going to take this and we're going to flip it around and we're going to say, all right, what's that look like? So now I'm going to take this 2x plus 2 and I'm going to stick it into the x minus 1. The problem is that that domain for x minus 1, that's the g function, right, has to be that. So when I take this 2x minus... when I take the 2x minus 2, okay, right here, and I substitute that in, yeah, my domain's all real numbers and my range is all real numbers. But the problem is some of those range numbers, those outputs, those aren't going to work as my inputs, okay, because it's not going to work into there. I'm going to get negative numbers. Uh-oh. Well, how do I fix that? So then what you do is you say, here's what I got to do. I got to take 2x plus 2, and I got to make sure that I set that equal to or greater than or equal to 1. Because when I do that, all the x values I'm going to get are going to work. All right, so now I'm going to solve this out like this. So I have 2x is greater than or equal to negative 1. So x is greater than or equal to negative 2. All right, so that's what my domain is. All right, x has got to be greater than or equal to negative 2, and I should be okay. So here I have greater than or equal to 1. I want to number line this guy. I'm going to draw a little number line here. So here is my 1. And I want all numbers greater than that, so it goes that way. All right. Now I come over here and I say, well, here's negative 2. And I need a...
Just to go back on solving that equation.
Oh, it's 1/2, isn't it?
Be negative.
Yeah. I saw somebody say that and caught me on that. Thank you. Erase. I probably couldn't wait with telling you that's what I meant, right?
And I have a question. Is this just to figure out the domain?
Yeah. It is.
Before we start the problem, G of f of x.
So, yeah, I mean, so if they ask you, you can go ahead and find it, right? But then they're going to ask you to state the domain of the composite function. So at some point, you have to go back and say, wait a second, I'm going to have some problems because I've got this square root of x minus 1 here, and x has to be greater than or equal to 1. So whatever numbers I get out of this orange thing right here, anyway, whatever numbers I get out of that, they're going to have to fit into that domain. Okay, they have to fit into that, or else it isn't going to work. So that's what we're doing. And we're trying to figure out, okay, what x values, all right, are going to work. So I have x is greater or equal to negative 1/2. So that would be back over this way. All right. So I have this. So here's kind of what I have. I have this domain of x is greater than or equal to 1, and I have this domain of x is greater than or equal to negative 1/2. So now let's go ahead and graph it and see what it says, right? See what we get. So I want to stop this share for just a second. Go into here. Oops. Come on. Where's my Desmos at? Here it is. And get into that. I don't know how I lost it in the first place, but it's probably around somewhere. There we go. Okay, so let's try this again. So I'm going to go ahead and come over to this side. And this, here we go. Maybe I will. Sorry, I'm having some issues here. No, it should work. Let's try it side by side here. Try to get it. Oh, there it goes. Okay, now I'm in business. There we go. Okay, so I'm gonna put these guys in here. So f of x, 2x plus 2, g of x equals square root x minus 1. Okay, and then we want to look at, we looked at that one, but I think I want to look at the other one. G of f of x. G of f of x. Okay. So when we took a look at this, remember I said, okay, we got two number lines here. We have a x is greater than or equal to 1, and we have, that's right here, okay? And then we have an x is greater than or equal to negative 1/2. So which one is the final domain? Well, it's obvious that it's this one, all right? It's got to be this one. So your conclusion is going to be, x has got to be greater than or equal to negative 1/2. That's okay because it still includes this guy, right? But this is the one that we really want, okay? And that comes from the idea that, again, these, we need to restrict these outputs so that they fit into that input. Okay, so we got to restrict them. So we had to make sure that 2x plus 2, right, was greater than or equal to 1. Because if it wasn't, then it isn't going to work. And that's where the negative 1/2 comes in. When we had it the other way.
Show us what it would look like if it was like an error. See what it looks like on the graph.
Say that again?
Can you show us what it looks like on the graph if there's an error so we can identify if we did something wrong?
You mean like, I'm trying to wrap myself around. So you mean where, so you mean like Desmos is giving you a false answer? Or?
Never mind. Never mind, I don't need anything, sorry.
Oh, no, that's okay. It was probably a good question. I'm just trying to wrap myself around that. So I think, yeah, you'll know if you made a mistake if you go and check them. I mean, that's kind of why I'm showing you this, because you can kind of check to see, hey, was I right in what I decided? And I would just get rid of those and just look at the composition here. And see, here the range is greater or equal to 0. And it's not going to ask you for that, but.
I'm a bit confused because we came up with the half and then the number 1, and I'm not understanding I'm just not understanding that.
Oh, no, that's okay. So, here, let me go back to that. I think I can clear that one up. So, what happened is that we were working through this, right? First of all, we said that the domain of the g function, which is right here, this is the domain of it, has to be greater or equal to 1, okay? That's what we said. It has to be. So whatever numbers that you get out of, so if we're taking f of g of x, so whatever numbers that we're getting, at g of f of x, whatever numbers we're getting out of f, those are the outputs, but those outputs become the inputs. So those outputs have to fit into that x is greater or equal to 1, okay? It has to fit in there. So the only way that's going to happen is if we say, okay, that function, f of x, here, has to be greater or equal to 1, or else the thing's it's not going to work for us. So that's why we went ahead and solved this. Well, when we did, we got that, okay? So then I came over to this number line, and I said, well, okay, so this guy is what the original g function was. Now I'm getting negative 1/2. Which domain do I go with, right? Well, according to Desmos, and if we graph it, we see that this is the one that I have to go with. Okay, so when you're figuring out domains, you want to follow that rule. All right, we'll do another example where you'll see it. All right, so you want to follow that rule.
Okay, that's helpful. So the 1 is inputted into the next problem.
Right. So, it's always when you start on the inside, you take that function, you get inputs, blah, 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 they go in. The outputs become the inputs for the one of functions on the outside. And if the function on the outside has some sort of a restriction, then we have to restrict the inner function's outputs so they fit in there, right? Or else they're going to block, right? They're just not going to get there. So if this is the inside function, right, and here comes its outputs, but some of these outputs aren't going in there because there's restrictions to it. All right, and that's what we're trying to figure out, is what they are. So find the domain of g, f of g first, find the domain of f and g. Yeah, you kind of do. So you kind of need to find, in a real complicated ones, which are ones I don't think you're going to see, where actually both f and g's have restrictions on domains. We can look at one like that. I think I have one. But most of the time, we're just looking at the one domain restriction. Okay. So let's look at another one. Maybe I can help you a little bit more here. So let's say that we have f of x again, And again, I'm going to just kind of make it simple. Let's go with a 3x plus 1. Okay, and let's do another g of x1. And let's make this one a little more complicated. Okay, we'll make it a little rational there. All right. Now, here, I'm just going to write down what the domain is. Okay, the domain of this, x cannot equal 0. So that's my problem. All right, that's my restriction. So when I'm putting things into that, I can't put 0 in there, because if I do, I'm going to have a problem, right? 0 is not going to work. So if I take f of g of x, now let's look at both of them, okay, so that you get both views on it. F of g of x, okay, let's go to look at the domain of this one. So the domain of this one, right, it's all real numbers. There's no problems there. So this should work out just great. So here we go. So the domain of this is x cannot be equal to 0, right? But any output that I get out of that g will go into f, because there's no problems with f. Okay, there's no problems. So let's do this composition. All right, so we're going to take the 1 over x, put that in where 3 is, so I'm going to get 3 times 1 over x plus 1. So I'm going to get 3 over x plus 1, right? So here we go. The only thing that doesn't work here is x cannot equal 0. All right, that's it. It just happens to be the same thing that's up there. It just kind of carries over. All right, but let's change it around. Okay, so now let's go g of f of x. All right, so g of f of x, now we're going to take the f function and put it where g is. So then I'm going to put here, let's write it like this, see if this makes sense to you. 3x plus 1. All right, I think that's all I have. Yeah, that's it. All right. Well, okay. That's what I have, right? Here's the problem. That can't be 0, because that's when I'm going to have an issue. So then I have to take that little f function, and I say, okay, f function, tell me when you're going to be 0. Well, let's see. We're going to subtract this little 1 over here. We have 3x equals to negative 1. We divide by 3. And, hey, guess what? Oops. The domain of this cannot be negative 1/3. Because as soon as negative 1/3 comes out of that f function, okay, I get a problem with g. And that's kind of how it works. Okay. So now you can kind of see it a little bit algebraically as we write it out. And you can also check it and see it a little bit in Desmos. So hopefully that kind of clears things up a little bit. Here, let's look at this one. Okay. So this is actually number 30 that's in the book. And then we're going to move on to, I think we got, oh, I got to do a couple more things with compositions. Number 30, which goes like this. F of x is equal to 1 over x plus 3. Okay. And g of x is equal to negative 2 over x. All right. And here's what they want us to do. They want us to find f of, I'm going to write it like this. Well, here, I'll write it like they do, just so it's consistent. F of, there we go. F of g of, they put that around there, x. They don't put the parentheses around the f and the circle g. I don't know why, but they don't when it's just straight up composition like this. But it's the same thing. So we're going to do G first, right? So let's just take a look at the domains here. All right. So what's the domain of this one?
X cannot be 0.
That's right. X cannot be 0. Okay. Can't have 0 in there. All right. Let's go up here and do the domain of this one. What's the domain of that one?
X cannot be -3.
Yeah, X cannot be -3. All right. So X cannot be 0. X cannot be -3. All right. Now we know. So let's work with this, right? So we got these G's here. Okay, so we're going to do G of X. All right. I see what the domain is. So I'm going to get all these outputs coming out of G, right? And they're going to be going into F. So that means that I can't have this -2 over X cannot be equal to the -3. Because if it is, that's the problem, right? Because I can't have -3 in there. So then what I'm gonna do now is figure out, well, what X values will give me that issue. So I'm just going to kind of solve this out, right? Now, I'm a cross multiply guy. I really like cross multiplication, so that's what I'm going to do here. So I have this, and then I'm going to divide by a -3. So here's my deal. When X is equal to -2/3, that's where I'm going to have my problem. All right? Okay, so now I'm going to do my composition. All right? G function is going to go in there. So I'm going to get 1 over -2 over X plus 3. All right? Now, they might do some fancy stuff with that, but it's not going to make it any simpler. Okay? I mean, what they'll probably do is find a common denominator on that 3. So you're going to get 3x. So they're probably going to have something that looks like this. They're going to have -2 plus 3x over x. All right? They'll have that. And they might even flip them. Since this is division, they might even flip this and make it x over -2 plus 3x, which is what that turns out to be. All right? Okay. They might do that. But really, I mean, that's not such a bad answer, right? So I just kind of, that's okay. If you give me that, I'm okay with it. All right? But remember now my domain, though, I'm saying for my final answer, hey, my domain, x cannot equal -2/3. Okay? Now, however, what about what I originally started with? Could x still be 0? Because if I put 0 in, is that going to mess me up? All right, so let's go take a look at that. All right, so I'm going to go ahead and type that in the Desmos. All right, and I'm going to check to see what happens there. I knew I had 2 of these buggers set up. Okay, good. All right, so here we go. I'm going to type this in. F of x equals, and let me see if I can get back to where I was. Well, side by side is fine. Oh yeah, there we go. 1 over x plus 3. Now remember, this is one of the tricky ones, right? Because there's issues with both functions. All right. Whereas before we didn't have this. This is one of the harder ones. The over x. All right. And now I'm going to put f of g of x. F of g of x. There we go. And off and off. Okay. Now what happened here? Why doesn't it like that? F of g of x. It doesn't even want to graph this. And it's probably because of the way that this thing is set up. Okay, now let me see if I type something in wrong. F of g of x. No, it just doesn't like it. And I think it's because it has double restriction, so it won't do it. Okay. So then in that case, all right, what we want to do is say, yeah, we have to also restrict it so that x, where's my little, here we go. Come on. I don't know why this isn't moving around. There it goes. It's kind of slow to react. We also cannot have 0 because of that domain there. Okay. So when you're doing these ones, where there's like double restrictions on the domain, they can be pretty messy. Like you said, most of them aren't like that. You're going to get pretty straightforward stuff where you're just going to get one restriction or everything's going to be all reals and it's going to be fine and dandy. All right. So it's a little confusing. That's what I'm saying. And you know, on a test or something, there'll just be one restriction. There's not going to be two. I mean, I'm not going to do that. So
this might be a silly question, but are we only finding the restrictions? Is there not a final answer?
So yeah, this was the final answer was right here. Okay, and they might simplify it to something that looks like that, but I'm okay with this guy. All right, but you then also, if they ask for domains, you got to include the domain. Okay. Let me show you in the book. I want to show you some stuff in that, and then we're actually going to be done with this, at least with. There we go. Okay, I want to show you a couple compositions that they have here. So let's take a look at this table, for example. I think this is one of our problems, but that's okay. We can look at number 9. So number 9, we're going to use this table here. I'm going to go with this little darker blue here. So we're going to use this table. So we want to find f of g of 1. All right. So you start on the inside and you start at 1. So here is 1 right here. Now you go to the g function first because it's on closest to the number. All right. The g function says, oh, g of 1 is 0 because here's g, right? G of 1 is 0. All right, so that input gives me 0. Here's my output. Now the output goes in the F. So then you come over here to this 0, and you go down to the F row, which is here. And that would be your final answer. -1. All right? So let's try a different one. All right? So let's try C, for example. Let's try C. Okay, so we're going to go g of f of -1. So I start at -1. So here's my -1. I go to f first. That's right there. That's -3. So -1 gives me -3. That output now becomes my input. So it goes there. All right, so here's -3. And now I go down to the g function, which is 8. So my final answer here is 8. All right.
Quick question.
Mm-hmm.
When we're doing this on the homework, do we have to show our work? Or can I just write -1, -8, whatever?
Yeah, there's really nothing much to show here because you're just using this chart, this table. So there's really nothing to show. Okay. And on any assignment, you can just put down the answers, right? Because assignments, I don't really spend a lot of time looking at those as far as, what you're doing. Again, mostly the quizzes and tests are the things that I'm going to comment on. All right. If I commented on assignments, I'd be still grading them. So it would take me a long time. Well, if it says, like, if you see this one where it's g of g, so how the heck does that work? All right, here, let me erase this stuff. So then g of g, what you do is you go, okay, start at -2, right? Here's -2. And we go to g. Well, g is here, so that's 3, right? That's the output. That output becomes the input. So I march way over here to 3. And now I go back down to G again, and I get 8. So that's the answer for that one. Okay, kind of a crazy looking 8, huh? But that's how that works. All right, you really don't worry about, it's G of G, so what? You just start here and go to G, and then you go over here and then go back down to G again. All right. Questions on those?
Mr. Patterson?
Yeah.
So one thing I found helpful was see where that globe is, or the Earth?
Yes.
If you click on that, it will take you into the book, and it'll actually show you those how to build on those. It'll give you examples and step you through. I don't know if you knew that or not, but
I did not. I've never experimented with that. I don't even know if it.
I just wanted to share that because that was very helpful for me in going through some of the, if I felt like I was getting stuck.
Okay. Good. Well, thanks for telling us that. Yeah, that's great. No, I've never really played with that stuff before. No, cool. Let me show you, now let's take a look at these ones where we have graphs, okay? So let's say we want to take a look at, let's look at number 11, and we'll look at A here. So I'm going to go G of F of -1. So I go to -1 on the graph, which is here. Here's my -1 on the graph, right here. Hopefully you guys can see that. Then what I'm going to do is go to the f function first. So here this is g and this is f. So I go up to the f function and it says, oh, -1 is 1. All right, that's cool. Now that's the output, but that output becomes the input. So then I go over here to 1. And now I go all the way up to g because that's the one that's on the outside. And g is 4, so that would be equal to 4. Right, that would be equal to 4. So let's try another one. Let's try this one. All right, so again, I'm going to start here at 4. So there's 4. Let me erase this junk so we don't get confused. So here's 4. Okay. I want G of 4 first. So I go up to G. G of 4 is 2. So now that 2, all right, is the output that becomes the input. So then I got to go to 2 right here and go down to F. That's where F is. And it's -2. So there's the answer. So you can also do compositions using a chart or a graph, right? Questions on that one?
Are they labeled? How are we telling the graphs, the F and the G apart?
Yeah, Daniel, so right here, I don't know if you can see my screen.
Oh,
see how it's labeled them? It's not really, it's not like bolded. It's just, you got to look for it a little bit. Okay. Let's stop this here. All right, so let's talk about inverses for a little bit. I know you're probably getting a little wore out, but inverses isn't going to be as bad. I think I have a link for something on here, and I'm going to kind of direct you into that way. Let's see, was that under here? No, was it under here?
Mr. Patterson, I had a quick question.
Yeah.
Not to be that guy, but I was wondering and curious how we would use this math in like the real world. How would you apply this information that we're learning into like a job?
Well, so who's asking this question?
Me, Hossie.
Hossie, okay. So, actually, you know, function composition, there's a number of different, like manufacturing, that would have multiple functions as far as if you're trying to complete a design or something. So like one machine might do one thing and another machine would do another. So that would be examples of function compositions. It's maybe not going to be necessarily like, here's a function now, you know, let's find the domain restrictions and all that. But the concept behind a production of something could be an example of function composition, and you wouldn't really even think of it that way. A math guy would, but you know, an ordinary person probably wouldn't see it that way. But that's what it is. Okay, and I would think, you know, I haven't computer programmed in, geez, way back in, I don't even, in the early 80s. But I bet there's some function composition in that. Okay, obviously it's changed, but I would think there might be something. So those of you who dabble in the programming and write code, I don't know if that exists there. Maybe you can shed some light on it. I'm not sure. Is that a good answer?
Yep, that's a good enough answer.
Good enough answer. Okay. Okay. So here's what we're gonna talk about inverses here. I'm gonna switch to this guy for this one. I bet I'm gonna have to make it thinner though. There we go. And if we don't cover, we'll see where we go on this. All right. I mean, I only got one section on Monday. So if we need to finish up function inverses, I'm okay with that. So we'll kind of see where we are here. We'll kind of go with this. So function inverse. So what I'm going to do is I want to put a link to a website, GeoGebra thing in the chat. It is on DTL, but we'll put it in the chat here. Let me see if I can. I think I copied it already. See if I can put it in the chat for you guys. Oh, cancel that. That would have been bad. Here we go. There's lots of stuff in there. Control V. Boom. All right. So I'm hoping that that will take you there. And if it doesn't, you can watch what I'm going to do anyway. Because I'll share this screen. I don't know if it will, but it might. Okay. So hopefully you're kind of seeing this copy of an inverse function. It looks kind of like this. All right. And what I'm going to do here is we got y equals x squared. It says f of x, but that's okay. All right. And we're going to take a look at the inverse of this. So what I'm going to do is do a reflect with the f of x on and off. I want to turn that on. All right. This green function is the inverse of the f function. All right. And we'll talk about where it comes from, but that's what this is. All right. So the green one is a reflection of the blue one, and they are inverses. Okay. So one thing we might notice right off the bat is that the green, which is the inverse, is the reflection over this dashed or dotted line. Okay, this dashed line. That dashed line is the y equals x line. So if I need to find graphically the inverse of a function, then I would reflect it over that y equals x line. Okay? That's the first thing about inverses. The second thing about inverses is, let's see if I can find a point here. So if I look at this point, all right, say, it won't tell me what it is. Let me put it here. So you can kind of see that this point is 2 and 4, or pretty dang close to it, right? 2 and 4. So on the blue one, it's 2 and 4. But on the green one, it's 4 and 2. So they switch positions. All right. So then if I have 2 and 4 on the f of x graph, then the inverse is going to be 4 and 2. So if I slide that down a little bit more to maybe over on this side, okay, so let's see if I can get it up to here. So now I have -2 and 4. So that means that 4 and -2 should be what it is on the green graph. And sure enough, that it is. Okay. So two things we should notice. One, we have a reflection. And two, that the x and the y coordinates switch. Right. So let me take rid of those points. I don't want that. Now there's one other thing that's really important with inverses. So here is this blue function. The green one is the inverse. There's a problem with the green one. Okay. Does anybody see a possible problem with the green one here?
Not a function.
That's right. It's not a function. Very, very good. And the way to check that out is to do this vertical line test, right? And a number of you use the vertical line test on your test. You know, you say, hey, this is a function because it passes the vertical line test. Yeah, good. I'm glad you did it that way. Okay. Yeah, absolutely. The green one's not a function. All right. So that creates a problem for us. So then what we have to do is we have to fix it so that it is a function. All right. So the way we fix that is we take the domain of the blue one. Where's that at here? Is it this way? Does it need to be refreshed or something here? Okay, let's try it again. Anyway, so we need to take this f green function, we need to change it so now it does pass the vertical line test. Okay. But the only way to do that is to restrict the domain of this blue one. So maybe if I go it won't do that. Huh? So I have to take the domain of this blue one here, and I'd have to wipe that side out, right? So I'd have to basically take this side and get rid of it, so that the graph is really, see if I can make this a little thicker and put it in blue, is really just this thing. All right. Now, you're not really probably going to see a lot of this unless you're taking 112. And when you take 112 and they do a lot of trig stuff, that's when you're going to do a lot of things with restricting inverses. Okay. But we're not going to do a whole lot with that, but it's worth mentioning just so that when you run into that. Okay. So there's a couple things going on here. Now, what's kind of cool about that is, let me clear this off. You'll also probably see up here that there's such a thing as a horizontal line test. Okay. Now, the horizontal line test shows you when a function doesn't have an inverse that is a function. All right. Because a horizontal line test is kind of just a reflection of the vertical line test, right? So the horizontal line test to say, hey, if a horizontal line test hits a graph of a function in 2 spots, then the inverse is also not a function. But if I take that blue guy and I restrict it down so that I had it before, then it does pass the horizontal line test. So this cool little thing here has a lot of stuff in it, right? Has a ton of stuff. Let's just change this to something like a line. There we go. And so there's a nice line. Now notice that it passes the horizontal line test, so there isn't going to be any issues with that. Okay. We'll do a reflection. There's my reflection, right? Here's my corresponding points. If I can get to them. I don't know if I can get to them. Nope, I guess I can't. Let me see if I can click somewhere. I haven't had that happen. See if I can do it this way. Nope, it still won't let me get up there. Okay. All right. So anyway, but you can still see the reflection. It passes the horizontal line test. The inverse passes the vertical line test. We're all good to go. All right. There's no need to do anything there. All right. It will restrict it, but we don't need to. Okay. Let's try cubic real quick. There's a cubic. Okay. Again, passes a horizontal line test. So we're good, even though you're thinking, well, wait, what about right there? Well, it's just that if it was zoomed in enough, you would see that it is totally increasing right there. Let's do a reflection. There's a reflection. Vertical line test. Okay. Everything's all right. Corresponding points. Now I can see them. All right. The X's and the Y's flip. Okay. So I like that little demonstration so you can see stuff. Hope I'm sharing. Yeah. Okay. I think we're going to be okay. So just kind of hang in there a little bit longer. All right. So first of all, let's talk about a function and its inverse. All right. Here's some of the things that we noticed. Number one, okay, the inverse oh my goodness. Is a reflection of the original function, we'll just say f of x, over the y equals x line. All right, that's the first thing. Okay. The second important idea is that the x's and the y's switch. So what we say there is we say that the domain and the range switch. X's and y's switch. The domain and the range switch, and the x's and the y's switch. Domain and range, comma, x's and y's switch. So they switch. So there's two important things. Other one is that horizontal line test, right? Horizontal line test. So here's how that works, right? So if a horizontal line, I'm trying to keep this as clean as I can here. Horizontal line intersects a function in two or more points, then the inverse is not a function. Okay? That's the horizontal line test. Hopefully you can see that. I was trying to write as best I can without having it be a real mess.
Could you scroll up for just a second, please?
Yeah, let me see if I can make it so that it's... Is that okay?
Yeah.
I'll scroll this down a little bit here. Okay, so I'm going to show you how to find an inverse, all right? And it's really not too bad. Okay, so we're going to give an f of x, and I'll give you a couple different examples here. Let's start out with something that looks like this, all right? And our task is to find this, okay? This is a symbol for inverse. Right there. If you see a little -1 next as a superscript on a function, then that means you're finding it's an inverse. That's what it's relating to. All right, so let's do this. First thing you want to do, set it equal to y. Okay? First thing, set it equal to y. Now we're going to use that one idea where the x's and y's switch. So we're going to switch the x's and y's. Now, once you switch the x's and y's, you solve for y. I don't know if your guys are seeing that. It just glitches on me. Solve for y. So I'm going to add 5. So I get x plus 5 equals 2y. And then we're going to divide by 2. So there's my inverse. X plus 5 divided by 2. So you use these ideas from that little GeoGebra diagram. The x's and the y's flip. Okay, you set it equal to y, flip the x's and y's, solve for y. Works every single time. It works. There's another way of doing it, but this way is the best way. Okay. So let's try another one. F of x, and this time I'm going to give you an x squared. Let's put a 2x squared, and we'll put a plus 1 at the end. And we want to find this. Now, this 2x squared plus 1 is a U shape. So we know it's not going to pass the horizontal line test. All right? Watch what happens. So when we go like this, right? Okay. What are we going to do? Flip the x's and y's. Solve for y. We move that over there. We get x minus 1 equals 2y squared. Divide by 2. Divide by 2. Almost there. X minus 1 divided by 2 is equal to y squared. Now, we got to get y. We don't want y squared. What do we do to both sides to get rid of the y squared?
Square root it.
Yep. So when you square root it, you get that. Okay. Now, most people are going to write it like that. Okay. But we also know that it should be a plus or minus. Because if I take the negative and I square that thing, I'm going to get positive, right? But most people don't. They just think, oh, it's just positive. Because of that, if you graph that, it will give you that curve that will pass the vertical line test. Okay? So really the only time that you're going to notice that you're going to have a problem is if you look at the original one and say, oh, wait a second, that doesn't pass the horizontal line test. When you do this procedure, it's all going to work. And it's, unless you change it to plus or minus at the end, which, again, most people don't do that. They just leave it like that, and we're good to go. Okay? But you should say up at the top someplace, hey, the domain of this is, whatever makes it that half. All right? You won't need to do that on your assignment, but in math, in a upper level math, they'll probably ask you to. Let's see. Oh, let me show you this. Let's do another one. Okay. So let's do a 1/2 x plus 4. So let's go ahead and find the inverse of this guy. All right. Set equal to y. All right. What do we do now? Yeah, flip the x and y, right? So x is going to go here. Good job. Y is going to go there. And we got a plus 4. Okay. Now what do we do? Yeah, we're solving for y. Good. So we're going to subtract the 4. Subtract the 4. We got x minus 4 equals 1/2 y. And either you can divide. What's that?
I said double both sides, sorry.
Yeah, now you can either multiply by 2 or divide by half, whatever you want to do here. Okay, so I'm just going to go 2x minus 8. And there's my inverse. Okay. So now what we're going to do is we're going to do function composition on the inverse and the function. So in other words, we're going to do this. F of f inverse of x. Okay. So I'm going to take this inverse function. I'm going to put it into that. So I'm going to take 1/2 of what I just got for an inverse, 2x minus 8, and add 4. Okay, well, here's what we get. This is going to go into here. And look what happens. We end up with x. All right. Now, remember what we were talking about? Compositions, they're not commutative, right? Yeah, Tyler, you're right. So now I'm going to take the f, okay, which was 2x minus 8, and I'm going to put the inverse into that. So my inverse was, oops, I think I got it backwards here. I'm going to take the 2 times my original f function, which was 1/2 x plus 4. 1/2 x plus 4. Okay, and minus 8. Okay, here we go. 2 goes into here. I get x plus 8 minus 8. Look at that. This is the only time, well, I shouldn't say it's the only time, but f and f inverse are always going to be commutative, and they're always going to give you x. So there's going to be some problems on the assignment that's going to say, verify that these are functions by showing that the compositions are going to be equal to x. So then you just write it out, and that's what you do. Okay. But other than that, that's pretty much all there is to the inverses. Again, as I said, I did build in we're only doing that one section because I anticipate there'll be some questions on this assignment. All right. So, yeah, I'm kind of anticipating that. So bring your questions with you on Monday, and we'll spend some time, and we'll spend as much time as we need to kind of going over this. All right. Anything you want to add? I pushed it to about 8:15. So anything you guys want to add before we sign out here?